When an AWS network issue hits production, most teams only see a timeout. But the real break can live in DNS, routing, policy, target health, or the application listener, which is why random guessing burns hours. A packet can fail before the app ever gets involved. The name may never resolve, the root may never exist, the security group or NACL may block the flow, or the load balancer may have no healthy target to forward to. Senior engineers troubleshoot by collecting evidence from the control plane, the data path, and the workload logs at the same time. That turns a vague timeout into a short list of testable failure domains. In this lesson, I will map the AWS observability tools that matter, show where each log source fits, and then walk the exact troubleshooting flow I use in production. DNS, routes, security groups, NACLs, target health, listener port, and log proof. AWS VPC monitoring includes VPC Flow Logs, IPAM, Traffic Mirroring, Reachability Analyzer, Network Access Analyzer, and CloudTrail. That list matters because each tool sees a different part of the problem and no single pane tells the whole story. Flow logs record accepted or rejected traffic metadata. CloudWatch logs show what the workload or managed service actually did. CloudTrail records who changed infrastructure or security settings. Those signals complement each other, but they are not interchangeable. IPAM is not a packet trace tool, but it belongs in the monitoring story because bad address planning creates overlap, exhaustion, and routing confusion long before packets start failing. Good troubleshooting starts with a sane IP design baseline. The real skill is choosing the right signal for the question. Are you proving path reachability, packet acceptance, API change history, DNS activity, load balancer behavior, or firewall verdicts? Once the question is precise, the right AWS tool usually becomes obvious. VPC Flow Logs tell you whether traffic was accepted or rejected at the ENI boundary, and they show the connection metadata around that decision. They do not show payloads, application exceptions, or why a healthy-looking target never answered. CloudWatch Logs are where EC2 instances, containers, Lambda functions, VPC endpoints, and several managed services leave runtime clues. If the network path looks clean but the target still misbehaves, CloudWatch is often where the truth finally appears. CloudTrail answers the change question. Who modified the route table, security group, NACL, load balancer, firewall policy, or logging configuration, and when did it happen? In real incidents, that timeline often explains why a path that worked yesterday fails today. The fastest investigations build one shared timeline: CloudTrail for configuration change, Flow Logs for traffic verdicts, and CloudWatch Logs for workload response. When those three align, the root cause usually stops being mysterious. Reachability Analyzer is the best first tool when you want AWS to model the expected path between a source and destination. It quickly shows whether routing, gateways, security groups, NACLs, or intermediate hops make the path impossible on paper. Network Access Analyzer is broader and more governance-oriented. Instead of testing one path, it checks whether your VPC network intent violates policies such as unintended internet exposure, overly open subnet access, or missing segmentation controls. Traffic mirroring is for the moments when metadata is not enough and you need packet-level visibility. You copy live traffic from ENIs to an inspection tool, but you use it deliberately because packet capture adds cost, privacy considerations, and operational load. The pattern is simple. Reachability Analyzer models the path. Network Access Analyzer audits intent. Traffic mirroring inspects packets. IPAM explains address ownership and overlap risk. Together, they give you shallow, medium, and deep layers of troubleshooting evidence. Always start with DNS. Route 53 query logs show whether the name was queried, which record answered, and whether the request pattern looks normal or broken. If the host name never resolves correctly, the rest of the path analysis is premature. ALB access logs are strong when you need HTTP and HTTPS evidence. Request paths, status codes, target responses, TLS details, and signs that the load balancer reached the target but the application misbehaved. NLB access logs are more limited because network load balancers operate at layer 4. They help prove connection attempts and target side behavior, but they do not give you the rich request context that ALB logs provide. Even with correct DNS and clean load balancer logs, a broken health check or an application listening on the wrong port will still look like a network outage to users. Healthy targets and the right listener port mapping are non-negotiable checks. In multi-VPC and hybrid environments, transit gateway flow logs show whether traffic actually crossed the transit fabric. They are how you stop blaming the application VPC when the request never cleared the shared routing core. Firewall logs are where you prove explicit inspection verdicts. They can show deny actions, rule matches, threat signatures, and whether the packet was dropped before the application VPC ever saw it. In centralized inspection architectures, you often need to correlate firewall logs, transit gateway flow logs, load balancer logs, and workload logs in one chain. That is the difference between proving the path and merely assuming it. The three phrases to watch are deny, drop, and no response. Deny usually means an explicit policy decision. Drop often means silent discard or failed return path. No response usually means the packet arrived, but the target never answered correctly. The production troubleshooting flow starts with two questions. Is DNS resolving, and is the route table correct for both forward and return traffic? If either answer is no, do not waste time inspecting application logs yet. Next, ask whether the security group allows the flow and whether the NACL allows it both ways. Security groups are stateful, NACLs are stateless, and confusing those behaviors is a classic source of false assumptions. Then, verify the target is healthy and the application is actually listening on the expected port. A passing network policy with a dead process or wrong binding still produces a timeout from the caller's perspective. Finally, inspect flow logs, CloudWatch logs, load balancer logs, firewall logs, and CloudTrail together. By this step, you are not searching blindly anymore. You are confirming which layer produced the deny, drop, or no response evidence. AWS Networking Observability is really about seeing three things clearly: what path was intended, what traffic actually moved, and what configuration or application behavior changed around the event. Use Reachability Analyzer for modeled path checks, flow logs for accept or reject evidence, Route 53, and load balancer logs for front door behavior, traffic mirroring for packet inspection, transit gateway and firewall logs for shared network proof, and CloudTrail for change history. A strong interview answer sounds like this: start at DNS, verify routing, check stateful and stateless policy, confirm target health and the listening port, then use logs and CloudTrail to prove exactly where the failure occurred and who changed what. If you build or operate AWS networks, keep this habit. Trace the request path from name resolution to target response, and only escalate to deeper packet inspection when the lighter signals stop being enough. Subscribe for more practical AWS, Terraform, and cloud engineering breakdowns.